So my name is Miro. I work on Filecoin station team in retrieval markets, and we are building Spark as a station module that will finally bring rewards to all wonderful people running station nodes. And I prepared a kind of overview setting the stage, but most of it has been already said. So the problem with retrievals is we don't measure it, so we cannot improve retrievals. And one of the reasons why we are not measuring it is because it's difficult to measure it. For example, the scale is tremendous. We have billions of gigabytes stored. We have millions of active storage deals we would like to check. And it's difficult to do it with reasonable costs. Then if you move beyond centralized solutions and you want to run this decentralized, permissionless, as a decentralized permissionless network, sorry, I'm nervous, then there is a big issue of trust. How do we trust the network? How do we trust the protocol? Was it designed properly? How do we trust people running the nodes? We don't trust them. So there are plenty of issues to solve there. And then finally, it's also a matter of incentives and funding. How can we pay people running the checker nodes, but also how can we pay people building all of this? And so we decided to build Spark to address all of these issues in the best way we can envision. And what is Spark, you can ask. And there are different ways how to look at this. One way is that Spark is a protocol describing how a network of permissionless nodes can measure whether a content can be retrieved or not. It's also an implementation, a Filecoin station module that's already running in 40 stations all around the world, gathering data, reporting measurements to our database. And it's also a reward system that we are building that will remunerate station operators for performing these checks, contributing their CPU and network bandwidth for greater good. And now I would like to show you a quick demo, what we have built so far. So basically, this is it. You don't see anything, and that's intentional because station should be running hidden in background. You don't notice it, so you can do your work on your computer while you are also helping the network. So it's running in the tray. The UI is very minimal. You can see how many jobs I have already completed. It's over 6,000. And soon you will be also earning Filecoin. That's coming. A more interesting part is the data we are collecting. And you can see we performed over 200,000 retrievals in the last week. We usually download over 3 gigabytes of data every hour. And we also have some interesting data about what can be retrieved and what not. And yeah, there are many errors. So most content cannot be retrieved yet. And this is similar to what the retrieval bot is seeing as well. Now, that's how it looks right now. And how does it work under the hood? When we were designing the Spark protocol, we had different constraints in mind. One of them was that we want to have a network of permissionless checker nodes so that anybody can run a station, run the checker, contribute measurements to the network. We also wanted to decentralize the orchestration, so there is not a single party deciding which node will do what, but we would like to have, or to allow anybody to run the orchestration. And then the uber goal for us is how can we produce measurements that the community can trust so that we can use this data to influence a reputation of storage providers. And at high level, we designed it on the concept of rounds. So from the network perspective, each round has 4 steps. In the first step, we define tasks, what retrievals should be performed. Then the network collects measurements from individual checker nodes. It runs some evaluation, most importantly to detect fraudulent nodes and filter them out. And then finally, we distribute rewards for the measurements which were considered to be valid. On the side of the checker nodes, there is another loop where the node picks a task. It performs the retrieval as defined by the task, and then it reports the measurement to the network, and then it picks another task, and so on. And if you look at the design, it's very generic, right? We have tasks, we have rounds, so it can be applied to almost anything. So the important part here is what is a task? And a task is defined as a content CID or object CID or payload CID, basically the data that we want to retrieve from the network, and a provider address from which we want to retrieve the data. Because you can have the same piece of content stored with multiple storage providers, and we want to ensure all of them are serving this data. What is important is the way how we need to design how individual nodes decide what task they will perform. And it's very important that the nodes must not be able to decide themselves what they want to test, because otherwise it would be super easy for them to collude with storage providers or cheat or just run only the task they find, I don't know, good for them to run, because it may be cheaper to run, or it can influence reputation of a particular storage provider. We also need redundancy in tasking, which means that we need multiple nodes to perform the same task. And this allows us to compare results reported by different nodes, form a majority or an honest majority, and then reason about which retrievals were valid and which were fraudulent. We also need, when we are deciding which nodes are going to do the same task, we need to form diverse committees so that we make it difficult for a single party to control the whole committee repeating the same task. Because otherwise, if I'm an SP, I can control the entire committee which is testing myself, and then I can report whatever results I want to get a nice reputation. And finally, we want this algorithm to be deterministic, so that if we want multiple nodes in the decentralized orchestration layer to run the algorithm, then all of them should reach the same result, the same set of tasks to be performed by checker nodes. And the idea we have is to form committees, which I already mentioned, and each committee is performing the same retrieval tasks. And we basically group stations into multiple committees. Different committees can have slightly different sizes depending on which nodes are online and offline. And this is given by the constraint of running on Filecoin stations, which are running on desktop computers. And if I close my lid, the station is gone. And it's difficult for us to predict when is this going to happen. So we need to be prepared for this situation when some nodes go suddenly offline or online. And to make it more difficult to cheat or for somebody to control a big portion of a committee, we decided to use IPv4 as a scarce resource. So basically, depending on which IPv4 address you are running on, we will assign you to a different committee. In this example, I would like to build 64 different committees, and then I can use the last 2 bits of your IPv4 address to decide which committee you belongs to. So I have an orange committee, a green committee, blue committee, and yellow committee. And now, even if you are willing to invest more money into this and you buy the entire /24 subnet of IPv4 addresses, which is reasonably easy thing to do, then you still get at most 4 nodes in the committee, which doesn't give you that much. And if you want to control more nodes, then you need to buy more subnets, and now it becomes more expensive, probably too expensive to do it. Then, after we found this, or we formed these committees, we need to decide what is the task that each committee should perform. And we call this process CID sampling. The idea is that we want to randomly sample all storage deals, or maybe all fill plus storage deal, or essentially all deals that are supposed to be retrievable, and find or pick one of them to test. And then we need a CID to test and the provider to retrieve data from. And again, we have several requirements how to design this. So first, we want to sample publicly retrievable data only, which is kind of an open question, but maybe we can use fill plus to begin with. What is important, we would like to have same probability for each per CID provider, so that on one hand, the algorithm is fair to storage providers, so we are not putting too much strain only on subset of storage providers if we are choosing only data stored by them. On the other hand, we also want to make it difficult for anybody to guess whether they will be selected for testing or not, because if the probability is same for everybody, then it's very likely that you will be tested now or in the next round. And then we again need this algorithm to be deterministic so that multiple orchestrator nodes can rerun it independently and reach the same results. And the way we are thinking about this right now is to perform sampling in 2 steps. The first step is looking on on-chain data, for example, on the storage market actor state, where we can find all active storage deals and then pick one of those deals. And that will give us piece CID. And as was already mentioned by Juan earlier today, that's not really what we should test, whether a piece CID can be retrieved. We need to test whether the actual object CID can be retrieved. So the second step is to go from piece CID to object CID. And what would be awesome if IPNI could help us with this, because IPNI already knows which PCID contains what object CIDs, but there is no API for us which we could leverage right now. So we are talking to the IPNI team to help us with building this. The other approach is what Kara mentioned, that we can try to download a chunk of PCID and find CIDs inside that. So there are different options we need to explore. And once we have the task defined, we perform the retrieval. And now the question is, how can we trust the node that it really did the retrieval it was supposed to do? And as Juan mentioned, proof of retrieval is not really possible. So we are kind of working around this using 2 different proof-like systems. The first one is what we call a retrieval attestation. And this gives us confidence that the checker node retrieve the content from the storage provider it was supposed to retrieve it from. And the idea is to modify the protocol for HTTP trustless gateway so that when the server returns back the car file with all the content we asked for, it will also append a small metadata block at the end, which will contain a signature, an attestation, or a signature that attests that we retrieve the content from this particular storage provider. It will be signed by their identity so that we know, we can later verify that, yes, this content was retrieved from the storage provider we selected, and we can use it for fraud detection. But this is not enough because we cannot be sure that the node actually downloaded all content. Maybe they just got the attestation from somebody else. So that's the second part we want to implement, and that's proof of data possession, where we would like to build an inclusion proof from all the data that the node downloaded. We will pick a random block and then build an inclusion proof for that. It should be quite small compared to the size of all data. And this will be submitted together with measurements and later used for fraud detection to detect nodes which did not download the entire data. And that's almost the end. The final step is how to reward the nodes for performing all this work. And we want to build a reward system based on the impact evaluator framework, which is a very nice concept running on-chain and has 3 steps. First, we measure what retrievals are reported. Then we evaluate what we measured and filter out fraud as part of this step. And then finally, we pay our rewards. And all will be good. So if I recapitulate how this all works, first we have the concept of tasking, where we decide which station nodes should perform which tasks. Then we materialize tasks as a concrete CID to retrieve using CID sampling algorithm. Then when the nodes are performing the retrievals, they need to provide retrieval attestation and proof of data possession. And then finally, we run impact evaluator to detect fraud and pay out rewards. What is our roadmap? In October, we would like to ship Spark beta version, which will have limited fraud detection capabilities. This is more about building the foundation on top of which we can quickly and easily add more fraud detection later. We would like to start distributing test fill rewards because IPC on mainnet is not yet, as far as I know. And we will have a static list of CIDs to check. And then for Lab Week, we would like to have a GA release where we will have slightly more dynamic selection of CIDs we are testing. If IPC is available on mainnet, we would like to also pay real fill rewards. And after that, sky's the limit. But what we need to do is improve fraud detection to get more confidence in detecting fraudulent behavior and then increase the rewards once we get more confidence. We would like to properly sample from the entire data stored on Filecoin. And finally, feed these measurements into reputation DAO and retrieval incentives efforts. And that's it. Thank you for your attention. You can find more about Spark on our GitHub. You can download Filecoin Station right now and help us test this. And when Filecoin start trickling down, you will receive it. And you can follow me on Mastodon if you are interested. And let's discuss.